Year 3. Hello, how are you? Welcome to your science lesson today. A bit different today. Today we're going to be doing an investigation into friction. So, remembering from last week, friction is the force created when two surfaces are brushing past each other. Okay. Last week we looked at the advantages and disadvantages of friction, looking at different objects and whether friction was a good thing or a bad thing. So for a slide, for example, you may have argued that friction was a bad thing because it would slow you down. On the other hand, maybe it was a good thing because then you wouldn't go too fast. Okay, it was interesting to see what you guys came up with. Today, we're going to be investigating the friction of different surfaces and how that affects our little toy car here. Okay, so I went out specially to buy this little guy. Okay, and we're going to be seeing how different surfaces affect this car's ability to go down this ramp. Can you see this ramp that I've created? I've had to run around the house and try and find all these different things to test out for friction. I thought it might be exciting to do our own little experiment. Okay, so first things first, we're going to do this experiment. This little car is going to go down this ramp. Now, we're testing different surfaces and I'll show you the different surfaces that we're going to put on here in a second. But when you're planning an investigation, it's really important to think about you're only measuring one thing. We're measuring the friction from each surface, okay? So we're measuring, we're going to be changing the surface every time on this ramp, all right? It's important to keep everything else the same, okay? We're changing the surface. Would it be a fair test if for every different surface I moved the ramp and changed the gradient of the ramp, the steepness of the ramp? Would that be fair if I did one like that and one like this? What do you think? No, absolutely not. It has to stay the same for every single one. Okay then, what if I changed the type of car? What if I used this one for one of them, and then I used a bigger car, and then I used a remote control car, and then I used another toy car? Would that be okay? No. We have to use the same car to keep everything that we can the same so that we really test what we've set out to test, okay? Let me show you the different materials that we're going to be testing out today. Right, so we have cardboard, okay? Cardboard first of all. Then we have tin foil. Then we have thin plastic, okay? Then we have thin cloth, let's say. And then let's say medium cloth, okay? This is a medium, slightly thicker cloth, as you can see. Then we have a thick cloth, okay? This is much thicker. And we also have felt, okay? It's quite thin, okay? So we've got all these different materials to test our toy car on. Now, an important part of an investigation. We need to make a prediction. Before we do that, let's think. If the car is on one of the surfaces and the surface makes it go slower, does that mean there is more friction or less? And if it goes more quickly, is there more friction or less? Have a think. You should be thinking that the slower the car goes, the more friction there is. The more friction is working on that car to slow it down, okay? Remember last week in the video, the guy had the sandpaper and he had the ramp so steep before it was holding on with so much friction. The slower it goes, or the more reluctant it is to move, the more friction is working on it. Like you going down a slide, if you're stuck at the top and really not sliding anywhere, there is so much friction acting on you to keep you up there and to stop you from moving. Okay, so the more the more slowly the car goes, the more the friction. Okay, now, important part of an investigation, we need to make a prediction. Which one of these surfaces do you think is going to create the most friction for our car? And which one of these surfaces do you think is going to create the least? Okay? On your worksheet, you have a little section at the top that says predictions. Okay? Take a moment to fill that in now. Okay? What I don't want you to worry about is if you get it wrong. Okay? Actually, I love science, and I can tell you that getting a prediction wrong is actually a really, really positive part of science, okay? If you predict something, you say, okay, this is going to happen, I think, and you get it wrong, that means that you are learning something, you are finding something out that you never knew before, okay? You thought something, you got proved wrong, and actually, that's a really positive step forward, okay? Your brain's going, whoa, I've just learned something I had no idea about before. That is crazy. And science gives us such a unique opportunity to explore things. And if you get things wrong or things surprise you, that's really, really positive, okay? So I don't want you, if your prediction comes out wrong, I don't want you to go back and change it at the end. I want you to be confident and go, wow, do you know what? I found something out today. I had no idea, okay? I'm going to make a prediction too. So why don't you pause the video for a second and we'll note down our predictions. Okay, are you ready? Time to start the experiment. Okay, you will need, so might have been useful then to get a pencil and a piece of paper, and then we can note our ideas down on our task sheet in a moment afterwards. You might also want to get your own something to measure the time. You might get an iPad, you might get a stopwatch, you might get your grown-up's phone perhaps, okay? You don't have to record the time if you don't want to, because I'm going to do it as well, but you can if you want to, okay? So, we're going to record the time in seconds it takes for our car to move from the top of the ramp all the way down to the bottom, okay? So, the minute, I'm going to count you down, and it's going to go. And then the minute it drops off the end of the ramp, we have to be really quick with our fingers and click stop, okay? Right, let's give it a go. I'm going to write down cardboard so that I'm ready to write down my measurement of seconds for this first one. Okay, are you ready? Fingers over your stop button if you are timing. I'm going to count you down. 3, 2, 1. Excellent. 1.22 seconds. Okay, let's get that written down. Okay, now we're ready for the next one. We're going to do tin foil next. What do you think? More friction or less friction? Retrieve my toy car. Okay, you ready? Remember to reset your timer because I almost forgot to do that. Starting at the top of the ramp. 3, 2, 1. Oh, interesting. 1.99 seconds, almost 2 seconds for that one. Didn't expect that, did you? Excellent. Let's get that noted down. Okay. Next up, we're going to do thin plastic. Okay. Thin plastic. Okay, you ready? Reset those timers. Right. Let's just make sure that's right. 3, 2, 1, go. Interesting. 1.65 seconds. Okay. Next up, let's do the felt. I don't quite have enough to go to the end of the ramp, but that will have to do. Okay, are you ready? Resetting those timers, starting at the top. 3, 2, 1. Do you know what? I didn't quite get my finger over the start button in time, so we're going to redo that one. You can note down the time if you got it, but I know it's a bit nerve-wracking, isn't it, to making sure you press start on time. So I'm going to redo that one. Okay. Right, let's try again, Miss Palmer. Are you ready? 3, 2, 1. Okay, 1.25 seconds for that one. So you can record down the timings that I get or the timings that you get. Don't worry if you're not timing, that's okay if you're just watching. Right, next up is the thin cloth. This might take me a second to set up, so just bear with me. As you can see, I'm using thin t-shirts. Okay, almost there. Just want to make sure there are no lumps or anything, because I don't think that would be very fair. Okay, trying to make sure that the ramp hasn't changed position too much. Okay, if I was being really scientifically accurate, I would measure how high my ramp is to make sure it was the same every time. But unfortunately, I've just moved house, so I don't have a ruler. Should have brought one from school, but I forgot. Okay. Right, where's my toy car? We're ready for thin cloth. Let's get thin cloth written down in preparation. Okay, let's get going. So, back onto your timers. Get ready, hover over the start button. 3, 2, 1. Oh, what does that tell you about the friction? Interesting, okay. Let me see if I move him over a bit. So we've got to stop timing and reset. Okay. Stop timing, reset. If I just move him over ever so slightly, he might have just been on a ridge or something. Okay, so we'll give it another go. Ready? 3, 2, 1. Oh, wow, that was quite a long time. Okay. I'm just going to redo that one. Just as he stopped, just to make sure. I got 1.83, what did you get? And we'll just make sure that that's the true time. If you're ever in doubt during a science investigation, you can always redo it, and that helps make sure that you got the right one, okay? So, let's see. 3, 2, 1. Oh, I did it again. Reset, he stopped again. 3, 2, 1. Oh, I got 1.46 that time. I'm going to do it once more. Okay, 3, 2, 1. Oh, I didn't do it right. I didn't get my finger over the button quick enough. Okay, ready? 3, 2, 1. Oh, I just clicked stop by accident. Oh my goodness. Cannot seem to get this one right. Last time. 3, 2, 1. Didn't even go anywhere. Again. Try again. 3, 2, 1. There we go. Okay, somewhere in the middle. 1.63. We'll go with that. Sorry, guys. I just couldn't get my finger to work properly on the button. 1.63. Okay. Medium cloth time. friction. So I wonder whether our car is going to go down the ramp for this one, or whether there'll be too much friction. We shall see, shall we? Okay, you ready? Make sure we're at the same angle. So starting to time. 3, 2, 1. Ooh, interesting. 2.12 for that one. 2 seconds. It's our first one that's over 2 seconds. So medium cloth. 2.12 seconds. Interesting. And last but not least, we have the thick cloth. Ready? Much thicker. Whilst it doesn't look it, it's quite furry on the top. So I'm wondering what that's going to do to the friction. Okay, ready? These are actually tea towels. Okay. Right, resetting our timers. 3, making sure it's nice and as flat as possible. 3, 2, 1. Oh, he stopped. Interesting. This tells you a lot about the friction here. The high friction or low friction? High friction. Okay, I'm just going to try once more. If I just give him another chance in another slot. Nope, doesn't seem to want to move on here. So last chance, Mr. Car. Let's put you all the way over here. 3, 2, 1. Nope, he's determined not to move. So whilst we didn't get time for this one, what does it tell you about the friction? That there's which material had the most friction? You should be saying this one, the most friction. This one, the thick cloth, had the most friction because the car would not move at all. Okay? Interesting. So rather than write a time for that one, I'm going to write no movement. Okay? You have a table to fill in with your notes, fill in all the surfaces and all the times, and then a couple of questions underneath. You tell me, did anything surprise you? Were your predictions accurate? Which was the surface with the least friction and which was the most? Okay, I hope you've enjoyed today's science lesson. I hope it was a little bit different for you. And I can't wait to hear your thoughts. Okay, write me a message as to how you found today's lesson. Okay, well done guys.